Hi Year 11, this was your second home learning paper. This is the feedback video where I go through the answers. So to get started then, number 1, the width of a rectangle is a whole number of centimetres. The length of the rectangle is 9 centimetres longer than its width. So we've got, for example, what have we got? Length is 9 centimetres longer, so maybe I'm going to do W plus 9 and W, right? Because if I've got W is the width, then the length is 9 centimetres longer. So I've got W and W plus 9. So this will also be W and this will also be W plus 9. The perimeter of the rectangle is less than 200 centimetres. Find the greatest possible width of the rectangle. So if I make W to be a small number, then this will all add up and be less than 200. It wants to find the greatest possible width. So it wants to find out what the biggest W can be so that all of this adds up and is still less than 200. So if I add them all up, I get 4W plus 18. So this thing has to be less than 200. So therefore 4W is less than 200 take away 18. So if I take away 20, that's 180. If I only take away 18, I'll be left with 182. And then I'll divide this by 4 to get what W has to be less than. So 182 divided by 4 gives me 45.5. So W has to be less than 45.5 in order to make this inequality be true. So that means that the biggest possible whole number that W can be is 45. Because anything less than 45.5 would work, and the biggest whole number that you're allowed to be is therefore 45. We can even check this out. So if I do 45, add 45, add 9. So that's those two, and then double this. That gives me a perimeter of 198. But if I pick 46 and then double that, it's too big. So you could also have done this with trial and error, and if you got 45, then you've got the right answer. Right, number 2. A rugby team played 6 games. The mean score for the 6 games is 14.5. The rugby team played 1 more game, and the mean score for all 7 games is 16. Work out the number of points that the team scored in the 7th game. So I'm going to work out a total for the first 6 games. So total for first 6 games. So the way you'd have got a mean of 14.5 is you would have a total number of, well, you'd have a total score and you would divide that by 6 and the answer would have been 14.5. So to work out the total, I'm going to do 14.5 times 6. So 87. So I'll just say that again. Because we know that the mean for 6 games is 14.5, it means the total had to be 87. Because 87 divided by 6 is 14.5. And that's how you work out what the mean of a set of numbers is. I would have divided the total by 6 and got 14.5. So working backwards, I've done 6 times 14.5. Similar idea for this second part. I'm going to get the total for the first 7 games. That's going to be 16 times 7. So 112. So there was some number of points scored in that 7th game. The way I'm going to work that out is by doing 112 take away 87. So that's 25. So there were 25 points scored in the 7th game. So that's quite similar to the one you saw in class. Hopefully you could remember the method to answer that. Right, number 3. we've got 4 containers and we're going to pour water in at a constant rate. So the first thing to make some note of is what this means. It means as the water is being poured in, it's not speeding up or slowing down. I'm not all of a sudden tilting it more so that more water falls out. I'm also not tilting it less so that the amount of water actually starts to slow down. It's being poured at a constant rate. And so the first thing to notice is if it was being poured into number 2, because number 2 just goes straight up, the amount of water is going to go up linearly. So what that means is 2 matches up with B, because it's not getting any faster or slower over time. As time goes by, the depth of the water goes up, and it doesn't get any, it doesn't get faster, it also doesn't get slower. Okay, so that's kind of how we match that up. So B goes with number 2, so we can kind of get rid of that. So we've done number 2 with B, so we just have to worry about the others now. So let's look at number 1. Number 1, if you think about it, at the bottom, it's a small area. So when I'm pouring water in, the depth of the water is going to go up quite quickly, and then it's going to start to slow down because up here, the surface area of the water is quite large in comparison to the small surface area of the bottom. So this is this one because it goes up and starts to slow down, kind of, The fact that this is straight means it's going to start off fast and start to get slower. So 1 goes with D. So we can cross that off. And then we're going to look at number 3 and number 4. So we just have to figure out the difference between number 3 and number 4. So number 3 is going to start off slow and then speed up, because if it was really thin and if you were pouring water into something very thin, the depth will go up really quickly. Whereas if it was really wide, it would go up really slowly. So if you notice, number 3 starts off slow, then speeds up, and then finishes slow. Whereas number 4 starts off fast, gets slower, and then faster again. So this one here, this starts fast, apologies about that, starts slow. It speeds up in the middle, and then ends slow. Whereas this one starts fast and it slows down in the middle and then ends fast. And so we just have to match those up. So this one here, as time is progressing, the depth of the water isn't going up very much. So this is starting off slow, then it all of a sudden gets faster. So hardly any time is going at all, and the depth of the water all of a sudden jumps up, and then it slows down. So this must be number 3. So A goes with 3. And let's just check, does number 4, it starts off fast, so the depth of the water goes up quickly, then in the middle part it slows down, and then finally it gets fast again near the top. So that must go with number 4. Okay, number 5. Slide 5. This was the first slide, so this is actually question 4. So the diagram shows the positions of 3 turbines, A, B, and C. So there they are, A, B, and C, and we've got 4.5 kilometers between C and B, and we've got 6 kilometers between B and A. It says A is 6 kilometers due north, okay, of B, and C is 4.5 kilometers due west of turbine B. So this is the picture, and this is the information. The first question says, what is this distance here? So that's the first question, is how long is that? So we're going to use Pythagoras for this. So this will be, if you label this for Pythagoras, this is A and B, because the hypotenuse is the longest side opposite the right angle is C. So I'll use a squared plus b squared equals c squared. I can use Pythagoras because it's a right angled triangle. So I've got 4.5 squared plus 6 squared. So I'm just going to use a calculator to actually figure out what this is. So 4.5 squared plus 6 squared is 56.25, which is what c squared is. So to get what c equals, I'm going to have to square root that. So square root of 56.25 is 7.5. So you should get 7.5 for that one. Now, this question, calculate the bearing of C from A. So I'm going to just change the color up. In fact, I might erase what's on this picture so that I can show you what to do for part B. So bearing of C from A, that means we're stood at A. So from A means we're stood at A, and then we look north. So this is how bearings work, remember. The bearing of C from A means I'm stood at A, I look north, and then the question is what is this angle? So that's that question. What's this angle? If I know the answer to this, then, well, I'd write it here because that's what the answer is, okay? So if you notice, this part here is just 180. That first part is literally 180. And then you've got this part that's in the triangle that you'll need to add on to 180. If you can work out this missing angle and add it to 180, you've got the answer to part B. But notice something. This is a right angled triangle. You're looking for an angle, and you know two sides. So this is, we're going to use SOHCAHTOA. So SOHCAHTOA. And we would label it ready for SOHCAHTOA. So we've got H, we'll go opposite the angle, that's O, and then A is the last one. And the numbers in the question are O and A. So let me just illustrate that. So we've got O and we've got A. So that means we're going to be using TOA. So let's just write down what TOA means. So it's tan of theta. So this is theta. Or you could call it, I guess, tan of A, because it's the angle. It's the angle at A, if you want to call it that instead. But tan of theta is opposite over adjacent. So tan of theta is, the O number is 4.5 and the A number is 6. So what you're going to do to get what theta is use the tan inverse button on your calculator. So that's shift and then tan. So it's tan inverse of whatever this is, so 4.5 over 6. And we're going to have to add that to 180, right? So our answer is 180 degrees plus our answer. So let's use the calculator again. So we're going to have to do tan inverse, so that's shift and then the tan button, of 4.5 over 6. And I might as well add 180 to it, because that's what my final answer is going to be. I'm in degrees, so this is going to give me the correct answer. So when I press equals, I get 216.869, blah, blah, blah. And it wants it to the nearest degree. So I'll round this up to 217. Okay, question 5. So we've got a prism. It tells us all measurements are in centimeters and all the corners are right angles. We need an expression in terms of x. So the final answer is going to have something with x's in it. And we need the volume of the prism. So first of all, let's remind ourselves that the volume of a prism is the area of the cross section multiplied by the, well, either depth or height of the prism, depending on how it's drawn. So in this situation, because it's kind of going into the page, you might call that the depth. So what we need to figure out is we need to figure out this area. So this is what we need to do. So it's this area. And then we're going to times that by this. So what we've got is, we've got this funny compound shape with a bunch of x's and stuff. We've got the depth of the prism. We need to work out this yellow area. Of course, it's going to have a bunch of x's and stuff in it. That's fine. We okay with that. And then whatever this area is, we'll then times it by x plus 1. And this will be the volume of the prism. Because the volume of a prism is, you work out the area of the kind of the shape at the top and, or the bottom, or the front or the back. Again, it depends on how it's drawn. And you multiply that by how either deep it is or how tall it is. Again, that depends on how it's drawn. So the shape is kind of like a U shape. It's a U shape all the way from the front to the back. And so the depth of it is x plus 1. So our first job is actually just to figure out this yellow area. So, well, what can we do? Let's have a think. So there's a few different ways of doing it. What I'm going to do is I'm going to split it up into 3 rectangles. So this first rectangle is x by x plus 2. Right, it's this x by this x plus 2. Then we have, well, we have the same situation over here. We have an x times what is altogether an x plus 2. Just going to pause for a second here while my computer sorts itself out. Guess I can get rid of the calculator while it's doing that. Don't need it at the moment. Hope everyone's all right, by the way. Right, it's sorted itself out. So this area here is also x times x plus 2, right? Because the area of a rectangle is how wide it is times how tall it is. So the last part is this kind of tricky bit in the middle that we kind of need to figure out. So let's first of all have a think about how tall this is. Do you see how the total height is x plus 2 and this height is 2x? So I'd need to do x plus 2 take away 2x. That will leave me with 2 minus x. So I'll say that again. The total height, and you can think of it being here as well, the total height from this part all the way down to this part, it's the same as this x plus 2. If I take away this 2x, I'm left with this part here. And if I do x plus 2 and I take away 2x, well, x take away 2x is minus 1x, and I've still got this plus 2, so it's 2 minus x. And then I've also got to figure out this. So in total, we've got 4x minus 1 along the bottom. I need to take away this x, and this will leave me with how wide this part is. So this is, well, it's getting a bit confusing. Let me just write it here. So this will be 2x minus 1. So this area here, so the kind of the purple area, is given by 2x minus 1 along the bottom multiplied by 2 minus x up the side, right? So let's just do a quick little grid method for that part. So 2x and minus 1 and 2 and minus x. So we've got 4x minus 2 minus 2x squared, and minus times a minus is a plus, and it just ends up being 1x. So this is equal to minus 2x squared plus 5x altogether, take away 2. Okay, so there's still a bit of work to do because we've got to have the red and the green area as well. So the red area the red area is just x squared plus 2x, so that's not so bad, is it? X squared plus 2x. And the green area is also x squared plus 2x. So the total area, sorry about this, this seems to keep crashing, it's a bit annoying. Let's use this color. Right, so the total area is x squared plus 2x plus x squared plus 2x. So they're the red plus the green, and then I've got to add this. So I'm going to take away 2x squared, I'm going to add 5x, and I'm going to take away 2. So we've just got to simplify this. So if you notice, I've got x squared plus x squared, but take away 2x squared, so that disappears. And then I'm left with 9x minus 2. So it's just 9x minus 2 is this area here. So this is 9x minus 2. And then I've got to times that by the depth. So it's just one last grid method. So I've got 9x and minus 2, and I've got x and I've got 1. So I've got 9x squared minus 2x plus 9x minus 2. So my final answer is 9x squared plus 7x minus 2. So yeah, clearly that's a really tricky question, but it does only involve, well, it only involves maths that you actually do know. It's just quite complicated. Right, question 6. The diagram shows a triangle DEF So it's this triangle here, inside a rectangle ABCD, and we have some lengths, so automatically I can see 2, 2, so this is going to be 4 over here. So you might as well fill that in, I guess. And it says, show that the area of this triangle is 8 centimeters squared. Okay, and we're told that this is 2 root 10. So I think we're just going to try to figure out some missing sides and then go from there. Okay, so let's figure out this one first of all. So what I would have for this one here is 2 squared. So I'm going to use Pythagoras because it's a right angled triangle. 2 squared plus 2 squared, which is 4 add 4 is 8. So instead of that question mark, I can write square root of 8. I'm not going to worry about writing it in surd form. If I did the square root of 8, that would simplify, but I'm just going to leave it like this for now. I'm just filling in all the ones that I possibly can. I actually don't think this root 8 is ultimately going to be needed. The more I look at this question, if you look, you can work out what DC is, because you know this length, and you're just going to use Pythagoras, but on this triangle at the top. And as soon as you know how long that is, you can work out the total area of the rectangle. You can also work out all of the individual triangles that you're not after, and then you can do the 3 little triangles taken away from the rectangle, and that's going to leave you with the triangle in the middle. So let me do that now. Let me take that slow so that I'm not being too confusing, because I appreciate I just kind of rambled there and maybe that was a bit confusing. But we're going to use Pythagoras using this side, and try to figure out what this is. So, well, let's call this a. So I know that a squared plus 2 squared is c squared, where this is the longest side, which is the c for this one. So this is 2 root 10 getting squared. Now make sure you square the whole thing. Very important to use brackets when using your calculator for this. So this is a squared plus 4. So this will be 4 times 10 is 40. Because if you square 2 you get 4, and if you square the square root of 10 you get 10. You could also type that into your calculator if you want. That's would give you the same answer, give you 40 there. So a squared is 36, and therefore we've actually figured out that a is 6. So this number here is 6. That's how long it is, which actually means that this is 4. And I know that that's 4 because it's 4 plus 2 has to make 6. So the rectangle area is 6 times 4 is 24. This area is 4 times 4 divided by 2, because it's half base times height. This area is 2 times 2 and then halve it. And finally, this area is 2 times 6 and then halve it. So 4 times 4 and then halved is 8. So let me get my colours back. So this has area 8. It seems to crash whenever I use different colours. It's just a bit annoying because it's quite nice to use different colours. Okay, it's fixed itself. So 2 times 6 is 12, halved is 6, so this had area 6. And then the last one, 2 times 2 is 4, halved is 2, so this has area 2. So what we're going to do is we're going to do 24, we're going to take away 8, we're going to take away 6, and we're going to take away 2, and that's going to leave us with this area. So I guess that's hopefully going to leave us with 8 then. So 24, take away 8, take away 2, take away 6 is 24, take away, well this is me taking away 10, so that's 14, take away 6 is 8, and it was centimetres squared. The whole thing was in centimetres, so this is centimetres squared. So yeah, don't be afraid to just, you know, use Pythagoras when you can, right? These were right angled triangles. You can find some missing sides. You can then work everything out. Okay, question 7. So we've got half AB sine C, and we're using that to work out the area of a triangle, of course. And it's actually a bounds question. So these are all bounds. So the lower bound for the area of the triangle, I want the smallest possible A, the smallest possible B, and I also want to check out what happens with sine of an angle. Do I want to use the upper bound or the lower bound for that? So that's something that we'll try out. So when you've got a bounds question, you do just want to write down all the bounds. So let's do the bounds for A first of all. So I've got 7.8 centimeters, but that's really 78 millimeters. Because you might see how it says it's in millimeters, so it's probably a good idea to write it out in millimeters. So to the nearest millimeter is 78, the next possible one would be 79, and then the previous possible one would be 77. So the bounds for A are 77.5 up to 78.5 millimeters. And we can do the bounds for B. It's the same idea. In fact, you could repeat the same picture, but I'm just going to write the answer. So it would be 51.5 up to 52.5. So if you could just draw the same picture, but instead of 78, you'd have 52, and you get this answer. And then for C, it's going to be 62.5 up to 63.5. And it wants the lower bound for the area of the triangle. So if you think about it, if you want the lower bound for the area of the triangle, you want to pick the lowest possible A and the lowest possible B. You want the sides to be as small as possible. That's going to give you a smaller triangle. Let's just see what happens depending on what happens with the angle. So I'm just going to try sine of 62.5. So that's 0.887. If I try sine of 63.5, it's actually bigger. So I do want to use the smallest possible angle. I want to use the smallest possible B, and I want to use the smallest possible A. So in my formula, I'm going to do a half times 77.5 times 51.5. So that's a half AB, and then times sine of, and remember we just showed I want to use the smaller angle, so 62.5. Also, you might guess that that's the one to use, and as it happens that would work out for you. It's not always going to, it won't necessarily always be like that in terms of just guessing, but sine between 0 and 90 does just increase as the angle increases, so it will work in situations like this. So anyway, let's do a half times 77.5 times 51.5 times sine of 62.5. And this is in millimeters squared. So let's be careful. This is in millimeters squared. So this is in millimeters squared. So how do you convert millimeters squared to centimeters squared? Well, remember 10 millimeters is 1 centimeter. So 100 millimeters squared is, well, I square 1, it's still 1, is a square centimeter. So you actually need to divide this by 100 to convert it into centimeters squared. So 17.701, if you want to be as accurate as that. Yeah, there you go. So that's how you do that one. Very careful at the end there. Remember, this was in millimeters. So this was millimeters squared, but the question wants it in centimeters squared, so you actually divide by 100. Okay, question 8. The scatter graph shows some information about 10 cars. It shows the time in seconds it takes each car to go from 0 to 60. For each car, it also shows the maximum speed in miles per hour. So we've got time in seconds to go from 0 to 60. So what this looks like is, if you take a long time to go from 0 to 60, so this would be higher numbers up here, your maximum speed also seems to be lower. Do you see that? If it doesn't take a long time to go from 0 to 60, you seem to have a higher maximum speed. So it's asking, what type of correlation does this scatter graph show? So correlation is a bit like what sort of gradient is the line of best fit. So you make sure with a line of best fit, you try to have the same number of points above as you do below. So it's not the easiest with that one, but I'm going to go with that. So there's my line of best fit, and I'm going to say that that has negative correlation because it's going down, so negative. And then the time a car takes to go from 0 to 60 is 11. And then the question says, estimate the maximum speed for this car. Okay, so it's just crashed yet again. So what we're going to do is we're going to use our line of best fit to get our estimate. Okay, so it's working again. So what you do is, based on your line of best fit, you would go along to 11, which, I don't know, what color should we make it? Green, and make it like that. And then you go along to the maximum speed number. and that's 120 based on my line of best fit, so 120. And if I look in the mark scheme, you'd be allowed anything from 117 to 123. So as it happens, mine is right in the middle of 117 and 123. But anyway, that's how you use a line of best fit. It's used to make an estimate like that. Okay, question 9. So Alex and Ben go to a cafe with some friends. Alex buys 4 cups of coffee and 3 cups of tea, and he pays £6.95. Ben buys 5 cups of coffee and 2 cups of tea, and he pays a total of £7.20. So this is a classic setup for simultaneous equations. We've got 4c plus 3t is £6.95, and we've got 5c plus 2t is £7.20. I'm just going to write 7.2. And then the way you solve these is you want to make the number in front of either the c or the number in front of the t be the same. And then you'll subtract. If one was a plus and one was a minus, then you would add, and again that would eliminate them. So the idea behind this is eliminating one of the variables so that you just get a very simple equation to help you figure out what one of the unknowns is, and then at the end you'll substitute back in to get what the other one was. So for the sake of argument, I'm going to eliminate c. So I'm going to choose to do 5 times equation 1. So 5 times this will be 20c plus 15t equals, and then whatever 695 times 5 is. So this is what the calculator is for. So 695 times 5. So that's 3475. And I'm going to do 4 times equation 2. So the reason I'm choosing this is not just because I'm doing it completely randomly. It's so that I end up with the same amount of c's. So if I do 5 lots of 1 and 4 lots of 2, I end up with 20c on both of them. So anyway, 4 times 2 is 8. And 4 times 7.2 is 28.8. And then you can do the subtraction pretty much straight away in this situation, right? If you look at this, you are taking the whole thing away. So 20c take away 20c, that's nothing, that goes. 15t take away 8t leaves me with 7t. And 34.75 take away £28.80. So let's work this out. 34.75 take away 28.8 is 5.95 or 5.95 if we're not talking about money. So now I'll share that by 7 to get what 1t is, and this is actually going to be my answer here. So t is 1 cup of tea. I need to do that divided by 7. So I get 85p or £0.85. Okay, so we've got what t is. So how do we now work out what c is? Well, you just use any of your equations and substitute in the t number to then get an equation that just has c. So for the sake of argument, let's substitute it in here because it's the smallest amount of t. Just again, literally just for the, you could choose any of them. It just wouldn't matter. So I'm going to have 5c plus 2, but we know what t is now, right? We know it's 0.85, so times 0.85. So that's the 2t, and this equals 7.2. So let me simplify that a bit. So 2 lots of 0.85 is 1.7. So plus 1.7 is 7.2. And then 5c will equal 7.2 take away 1.7. So 7.2 take away 1.7 is 5.5. And then I'll share that by 5 to get that c is 1.1. So in terms of money, that's £1.10. And you could literally have done this same method, but you could have used the first equation, you could have used this third one that I got here, you could have used this fourth one. I mean, let's just even check. Let's check using the fourth one. So I'm using this fourth one here. Can you see this one? I'm going to check using this one. So I'll do 20 times £1.10, and I'm going to add that to 8 times 85p, and I should get 28.8. And I do. So you could, as I say, you could have used any of them. So that's the method of doing simultaneous equations. Right, welcome back. So we got up to question 11. So to get started, in the USA we are paying $20.88 US for 6 gallons of petrol. In Russia, we're paying 800 rubles for 25.58 liters of petrol. So right away, we've got different currency and we've got different measurements of capacity, different units of capacity. So have gallons versus liters. And we're asked to compare the prices of petrol in the two countries. So we have to work out where is it more expensive actually to buy petrol. So in order to fairly compare these, we need to be measuring them using the same types of capacity. So we need them either both in liters or both in gallons. And we also need the currencies to be the same. Now, if you actually look at the little table before answering this question, you'll notice there is no direct conversion between dollars and rubles. There is an indirect conversion that kind of takes you via euros, because it has euros and rubles and dollars and euros. So it's quite complicated. Based on this table, it looks as though it's going to make the most amount of sense to choose euros to be the currency that we convert them both into. And that's just because we have information about both. Right? We have information about euros in both of these for rubles and dollars. We can choose whether or not we want US gallons or liters. I'm just going to choose liters because it's what we're most used to, right? So let's first of all do USA. So we've got 20.88 US dollars gets 6 gallons. Straight away I can convert that into liters. It's not that hard to do that because it's 1 gallon is 3.79 liters. So 6 gallons will be 6 lots of 3.79 liters, because every single US gallon is 3.79 liters, right? 1 gallon is bigger than 1 liter. So this is 22.74 liters. So we can now compare that with the Russia statement, because the Russia statement also has liters. We are going to have to do something else at the end, because in order to properly compare them, we need to be using either the same amount of liters or we need to be using the same amount of money. But we'll worry about that at the end. We also need to convert the US dollars into euros. So we want to convert this to euros. We could convert it to rubles if we want, and then we would be able to compare it to the rubles. But the conversion that takes us from dollars into rubles is a little bit complicated, because we've got $1 is 0.77 euros, and then we've got what, 1 euro is 40.63 rubles. What I'm going to choose to do is convert them both into euros, because we can just directly utilize these bits of information. So anyway, 20.88 US dollars is how many euros? Well, $1, so I might write it as a little ratio. So dollars to euros is 1 to 0.77. And we want to know, if I had $20.88, how many euros it would be. So we just have to times by 20.88. So I have to do 0.77 times 20.88. And so we want to be as accurate as possible as well. So I'm going to write this down in full, even though it probably won't make too much of a difference. If it was really, really long, I would probably round it a little bit, but since it's not that long, I'm just going to write it down. So what we've got is for the USA, so I'm just going to summarize the information. So for the USA, it's 16.0776 euros gets 22.74 litres. So now I need to do a similar thing, but with Russia. Russia is actually a tiny bit easier because Russia is already in litres for the petrol. So let's write Russia. So this has crashed again. What we're going to do is I'm going to write the information out, and I'm going to convert the 800 rubles into euros. And then what I'll have is Russia, and it will be however many euros gets however many litres. So it's back, it's working. So Russia, we have 800 rubles. And that gets you 25.58 litres. So that's actually already in litres. So we're actually quite happy about that because it's already in litres, right? But the 800 rubles, we need to convert that into euros. So we've got euros to, I don't know what the symbol for rubles is, so I'm going to write rubles. So we've got 1 euro is 40.63 rubles, and I want to know how many euros 800 rubles is. So what I need to do is multiply by 800 over 40.63. You could also think of it as I need to do 800 divided by 40.63. This would tell you what the multiplier was. I mean, that is actually what we're doing. And then that would tell you what 1 euro is. So anyway, I'm going to do 1 times 800 over 40.63. So that is, and this is where I will definitely have to round, so 19.6899, let's call it that, because that's so close. So 6899. So that's rounded. So I'm just going to write this in this bubble here. So Russia, you only spend 19.6899 euros, and that gets you 25.58 litres. Right, I can see the calculators in the way. Let's get rid of that. And so actually, it's not immediately obvious because look, it's fewer euros, but for fewer, well, for less petrol in the USA, and it's more euros, but you do get more petrol. So we actually have to be able to fairly compare these. So what we're going to do is we're just going to work out in the USA what 1 euro gets you. And we'll do the same thing with Russia. So in the USA, 1, and it's crashed again. Every time I choose a different color, it crashes. What does 1 euro get you? How are you going to work this out? Well, you're going to divide by 16.0776. That would get you down to what 1 euro is, and you must also do 22.74 divided by 16.0776. So it's a bit like saying, well, you know, if I'm paying 16 point whatever euros and I get 22.74 litres, what would only 1 euro get me? So I'm going to divide by the 16 point something. So let's do what 1 euro gets how much in the USA. So I'm going to do 22.74 and I'm going to divide that by 16.0776. So that is 1.41. Apologies, the calculator went away. So 1.4144 litres after rounding. Okay, so 1 euro gets you about 1.4 litres in the USA. In Russia, 1 euro, so I'm going to do 25.58 this time, but I'm going to divide it by 19.6899. So 1 euro gets you 1.299 litres. And the idea is, well, it's better in the USA, right? Because 1 euro gets you more petrol in the USA. So let's just double check what it says here. Well, I must say it is not immediately obvious based on the answer. Mark scheme is very complicated for this question. Cost per litre for US petrol. So I'm just going to double check. That if I do 1 over 1.4144, I get 0.707. Okay, I do. So this is right. And if I do 1 over 1.299, I get 0.77. That's great, right? So, right, my apologies for that. The marks, there's so many different ways of answering this question that the mark scheme as provided doesn't actually have all the possible kind of variations in it. But thankfully my numbers are actually correct. So I've just verified that. And basically the conclusion is it's better value. So it's crashed again. I'm going to have to edit all these, I'm going to have to cut all of these crashes out. There's so many of them. It's so annoying. Right, better value in the USA. Okay, that's the answer. Right, number 12. Okay, so that's 0.3, that's 0.3, that's 0.7, that's 0.3. Work out the probability that the spinner lands on 2 different colors. So that's 0.7 times 0.3. So that's green, then red, plus 0.3 times 0.7. Have you noticed just how inconsistently difficult some questions are? It's really crazy. Like that last one and some of the ones before have been really hard, and then there's this one, which I'm not being funny, like is not hard if you can remember probability trees. So there you go, 0.42, and it's worth a whole 5 marks. Okay, so number 13. Okay, back to a really hard one again. So we've got a trapezium with an area of 5 root 6. Okay, and we know its height, and we are trying to figure out what k is. Okay, so as horrible as this looks, if you remember how to work out the area of a trapezium, you can at least get some marks on this. So what you actually have is you have 4 plus k, right? That's if you add up the 2 parallel sides, and then if you times that by root 3, which is how tall it is, you're supposed to get 5 root 6, because that's what the area is. Oh, and halve it, of course. You've got to halve it, right? Must halve it. So, okay, let's deal with the fact it's halved. Let's just double everything. So instead I could write 4 plus k times root 3, and that would actually be 10 root 6. Okay, so if I do that plus that and times it by root 3, if I don't halve it, then this would be 10 root 6 instead of the correct 5 root 6. The formula really is add up the two parallel sides, so 4 plus k, times it by how tall it is, which is root 3, and then halve that answer. And that is what is 5 root 6. So hopefully you can see that if I times both sides of this equation by 2, I have the same numerator. It's now not being halved anymore, and 5 root 6 is 10 root 6 now because it got doubled. So okay, so what's 4 plus k then? Well, it's whatever 10 root 6 divided by root 3 is. So let's work that out on the calculator, because it's a calculator paper. So 10 root 6 over root 3. I actually think this question looks a lot harder than it is. So this is 10 root 2. So k is 10 root 2 minus 4. So 10 root 2 minus 4. Do you see how that's this format here? It's 10 root 2 minus 4. So I guess, like, you know, A is 10, B was 2 in this question, and this C was 4. Right, number 14. The diagram shows a large tin of pet food in the shape of a cylinder. The large tin has radius 6.5 and height 11.5. A pet food company wants to make a new size of tin. The new tin will have a radius of 5.8, but the overall volume has to be the same. So I guess the height will be a bit taller to compensate. We have to work out exactly how tall it is. So I think the probably the most sensible first step is to work out what the volume of the original thing is. So the original volume is, well, you need the area of the cross section. So you need this area, because it's a prism, it's a type of prism, it's a cylinder. The cross section is a circle, and you're going to times that by how tall it is. So you've got pi times 6.5 squared times 11.5. So I'm going to write this in terms of pi just because it's probably nicer that way. So let's just do 6.5 squared and times it by 11.5. So this is 3887 over 8 pi. Of course, you can get this as a decimal as well if you really want. So if I times that by pi and press the SD button, okay, so the volume is like 1526.4 centimeters cubed. But I tell you what, it's just easier to leave it like this in terms of pi. So the new tin will have a radius of 5.8 centimeters. So let's work out what the new the formula would look like for the new volume. So the new volume will be pi times 5.8 squared times by, we don't know the new height, do we? So we're going to times that by h. That's what we're trying to figure out. So this is like one of those where it's an unknown, it's part of the question, you might as well give it a name, and then it will feature itself in some sort of equation that you can then solve, right? So this h is the h of the height for the new tin. Well, this volume will be pi times 5.8 squared times the new height. But what's the idea? Well, it's still got to equal this, hasn't it? It said it had the same volume as it did before. Right, that's literally what it said. It said it's got the same volume, and in fact that's the sentence that this arrow is pointing to. So you are just solving this equation. So I'm going to divide both sides by pi, because both sides are currently being times by pi. So I've got 5.8 squared h is 3887, so 3887 over 8. H will be 3887 over 8, and I've just got to divide that by 5.8 squared, and then that's what h is. So that's a job for my calculator. So 3887 over 8, divide that by 5.8 squared. And we want it to one decimal place, so 14.4. 14.4, great. Okay, question 15. Right. So if you look at the fraction on the left-hand side, that's clearly quite complicated. If you look at the fraction on the right-hand side, it's a lot simpler. So what's probably happened is that this has been simplified. Now, the only way you can simplify a fraction is by dividing top and bottom by the same thing. For example, if I have 15 over 20, then you can write this as 3 times 5 on the top and 4 times 5 on the bottom. And then you can cancel top and bottom by dividing top and bottom by 5. So you're left with 3/4. I've just noticed I'm in the way there. Let me just move me for a second. So 15 over 20 is obviously the same as 3/4. Now notice you can't simplify a fraction by taking something off both top and bottom. Like I can't simplify this by taking away 5 top and bottom. That would be 10/15, which is not the same as 3/4. You have to divide top and bottom by the same number. So with that in mind, what we're going to do to simplify this horrible algebraic fraction is we're going to write the top as simply as we can. We're going to factorize it, and we're going to hope that there's a common factor top and bottom. That's how this is going to work. So there's going to be something that we can divide by top and bottom. So let's work out the numerator. So the numerator. So I've got n plus 2 squared minus, and I'm going to put it in big brackets because I want to figure this out, and then I'm going to subtract it. So let's work out what n plus 2 all squared is. So we've got n and 2, and we've got n and 2, and we should also figure out what n plus 1 all squared is, because that's literally in the question. So we've got n squared, we've got 2n, we've got 2n, and we've got 4. Here we've got n squared, n, and 1. So the numerator is really n squared plus 4n plus 4 minus n squared plus 2n plus 1. Now I'm taking this entire thing away. So this, take away n squared, take away 2n, and take away 1. So this is n squared plus 4n plus 4. Take away n squared, take away 2n, take away 1, which finally simplifies out. N squared take away n squared is nothing, 4n take away 2n is 2n, and 4 take away 1 is 3, so plus 3. So this horrible top of the fraction is just 2n plus 3. That literally has simplified to just 2n plus 3 on the top. Now let's simplify the bottom. So I'm going to write equals there. The top is still the same. That can't be simplified anymore. This is n lots of, because the thing that's in common to both of these terms is n, and then I'd have to times by 2n add 3. Now if I put the top in brackets, hopefully you can see what is common to top and bottom, what I could divide by top and bottom. I'm going to divide by 2n add 3. So if I divide 2n plus 3 by itself, I get 1. And if I divide this product, so whatever n is, if I times it by 2n plus 3 and then divide it by 2n plus 3, I will get back to n. Right, it's a little bit like what we did in just the case of some numbers. It's like I'm dividing top and bottom by the same thing. And of course, there's really a 1 there, isn't there? So it's 1 over n, which is what we want. Okay, number 16. So this is the hardest type of subject rearrangement that you could be asked for, and it's a really good thing to try to practice actually, because it's got a very set method. It's something we've done in class before quite a bit, and it's something that we will keep practicing. So this is what happens when you've got basically just a letter by itself. Well, I guess it could be a little bit more complicated. Maybe there's a square root over here, and so the first thing you do is square or something like that. But most of the time it just looks like something like this. So the reason it's so horrible is because you want r by itself, but r is in two different places, on the top of a fraction and on the bottom of the fraction. So it's not very clear how you're going to get r by itself. So this is kind of the method and also the mentality that you want to have. So we've got this division here, and we don't like division. So we're going to times both sides by r minus 3. We're going to get rid of this r minus 3 on the bottom. So I'm going to have p times r minus 3 is 2r plus 5. So all that's happened is that this r minus 3, I've times both sides by it. I've been left with just 2r plus 5. I'm no longer dividing by r minus 3 because I've now times by it, and p is now obviously being times by r minus 3 because I've times both sides by it. Right, so that's the very first step. The second step, we don't like brackets, right? We want to get rid of the brackets. So we're going to have pr minus 3p is 2r plus 5. And then what you want to do is you want to get all of the terms that involve r onto the same side. And you want to get all of the terms that don't include r onto the other side. So let's do that in a couple of steps. Let's make the left-hand side be where all the r's are going to live. So let's take away 2r from both sides. We've got pr minus 3p, and I'm going to take away 2r from both sides. So I'm left with 5 on that side. And then this minus 3p, that doesn't have any r's in it, so I want it to go and live on the other side. So this is pr minus 2r is 5 plus 3p, right? Because I've now added it to the other side. And now we have to kind of think in reverse. Now we do like brackets. So you see what you can do with this is you can factor out the r. So it's r lots of p minus 2 is 5 plus 3p. See that the r is common to both, so you can take it out the front and write a bracket, r times p, r times 2. And then the very last step is to do the very opposite of what we started with. We now divide, so we're left with r equals, and it's 5 plus 3p, and I'm dividing that by p minus 2. So I'll write the answer here. So 5 plus 3p over p minus 2. So this is something that we're going to practice a lot in class, okay? Because this could theoretically be, after a bit of practice, it could be 4 marks that you can get every time, because the method is always going to be the same. And you can just practice the method. Right, number 19. S is inversely proportional to the cube of t. So this means S is k divided by t cubed. That's what that means. If it was directly proportional or just proportional, it would be k times. But since it's inversely proportional, it's k divided. And now it tells you when t is 4, s is a half. So let's write a half equals k divided by 4 cubed. So that's a half is k divided by 64, which written as a fraction is just that, by the way. So you got a couple of ways of figuring out what k is. You could times up by 64, so you could have 64 divided by 2 is of course 32. You could also think about what the equivalent fraction would be to a half if a 64 was on the bottom instead of 2. So of course k would have to be 32. So therefore we've got k is 32. So then we've actually got our little formula. S is 32 over t cubed. Let's just check that this works, so before we do anything else. If I do 32 over 4 cubed, which is this t number, I should get a half. Great, so it works. So now the question says, what's s when t is 8? So instead of 4, I'm just going to make it 8. So you get a 16th. Right, number 20. Find the equation of the line perpendicular to the line n that passes through 0, 1. Okay, so it's got to go through here. And if it's perpendicular, do you see how this original line is going 1 along 3 up, 1 along 3 up? So the line that's going perpendicular is going to go 3 along 1 down. So it's going to go like 3 along 1 down. Right, so that would be there. And if I fill that in, so that's something quite useful to try to remember. Is there we go, is that if you're perpendicular, instead of going 1 along 3 up, it's now 3 along 1 down. Okay, so if you have a look, let me see if I can erase this bit of working. I have a 90-degree angle there, and that's what perpendicular means. Another thing which you may be able to remember, and this is actually really how you're supposed to do it, is you're supposed to figure out that this gradient is 3 by literally, it's 1 along 3 up. Okay, so it's a gradient of 3. We really need to be at the point where that's fine. So therefore the perpendicular gradient now, you've been taught this, but you were taught it a long time ago, and it's something that I have yet to remind you of in class. If you want the gradient of the perpendicular, it's the negative reciprocal. Not just the reciprocal, but the negative reciprocal. So the reciprocal of 3 is 1/3. The negative reciprocal of 3 is minus 1/3. So you could think of this as being minus 1 over 3, and then this is how far up over along, because it's a gradient. So it's like I go, well, the 3 is the number that I go along, and then minus 1 up is really 1 down. Sorry about that. Up over along is the gradient, isn't it? So if it's a minus 1 up, that's really 1 down, and then it's 3 along. So 3 along, 1 down is exactly what it needs to be at right angles. So anyway, the equation of the line is y equals mx plus c, but you know what the m is, it's minus 1/3, and you also know what the plus c is, it's 1, because it crosses at 1. So it's y is minus 1/3 x plus 1. Because you literally, well, that's it. You have y equals mx plus c, you know what m is, it's minus 1/3, either visually or by remembering a little formula. And you also know what the plus c is because it literally crosses, it tells you that it crosses at 0, 1, so you know the plus c is 1. Right, after a bit of technical difficulty, here I am doing question 21 again, hoping that it'll work okay this time. Right, we have 3 points that lie in order on a straight line. So let me start by making a little sketch. I'm going to say A is about here, so this is point A, which is 2, 5. Then B is kind of 2 along and some amount up. So let me put B there. In fact, just so that it's going to look a bit more accurate, let me put it there. So B is 4P. And then C, going to be somewhere over here. C is Q17. And so the first thing to say is I know that they lie on a straight line because it tells me so in the question. So something like that anyway. So I'll try my best there. Just a little sketch. So that's the straight line that they're supposed to lie on, that it literally says in the question. They lie in order, so it goes A, then B, then C. So we also know that. And the reason I've spaced C out like this is because it tells you that the distance from A to C is 4 times the distance between A and B, which means this distance from A to B is 1/4 of the total distance from A to C. And then we need to figure out what the number P has to be to make this be true, and we need to figure out what the number Q has to be for this to be true. Now this is an example of a question that looks a lot harder than it really is. So let me try to illustrate why. So first of all, how far along do we go to go from A to B? Well, we go 2 along. And how far up do we go? Well, this is something we don't know, so we're going to have to write P minus 5. Okay, so we're just going to write that and hope that we can figure out what P is. Now, this is where it likes to crash. It likes to crash when I choose different colours, but it seems to be behaving itself. Although no, it has just crashed. So let me just, while it's doing this, try to explain what it is I'm going to do. So because I know that the distance from A to B is, say, a quarter the distance from A to C, this 2, this red 2, is going to be a quarter of this green distance along, and the P minus 5 will be a quarter of this height. So let's do the height first. It goes from 5 up to 17 up, so that must be 12. And this along number, unfortunately, we don't actually know what that is either. It involves Q. We have to do Q take away 2. So this is where it really likes to crash a lot, but let's just hope. So the red 2 is a quarter of the Q minus 2. Okay? Because whatever this distance is, if you times it by 4, you should get this distance, because of the way straight line graphs work, actually. And we can also say, well, we can say that P minus 5 is a quarter of 12. Right, whatever this height is, it's a quarter of the height to go all the way up. Right, this is the height to go from A to B, this is the height to go from A to C, and we know that that must be a quarter of that. But now this is actually enough information to answer the question completely. Because 2 is a quarter of 8, isn't it? 2 being a quarter of 8 means that Q minus 2 is 8, which means that Q must be 10. And P minus 5 is a quarter of 12. Well, a quarter of 12 is 3, so this thing has to be 3, which makes P 8. And that's how you answer the question. Right, leave a like if overall this video has been helpful. I know that some of the questions were quite tricky, but remember, it's not always about getting all the marks on a question. Sometimes it's just about getting 1 out of 3 or 2 out of 3 instead of 0 out of 3. Okay, the aim is to just do as well as you can on each individual question. Right, thanks for watching. As I say, leave a like if it's been helpful, and I'll see you in the next one.